Okay, shall we start? इसको बंद कर लो। Okay, let us start the session. Very good morning to one and all present here. Distinguished guests, Sir Parvez Alam, Syed Parvez Alam, welcome sir. Welcome to the session. Distinguished guests, faculty members, participants and students, I cordially welcome you all to this session today. I, Prabhali Datta, HOD, Civil Engineering Department of Bengal College of Engineering and Technology, welcome you all to this 5-day online short-term training program, STTP, on recent trends in sustainable development, which is being organized by the core branches of engineering and basic sciences, including English. I welcome you all. Welcome, sir. Welcome to the session.
Thank you very much. Thank you very much. Good morning. Good morning to all.
Good morning. Good morning. Sir, let me give a brief introduction, sir, just before we start, okay?
Okay.
ठीक আছে?
अगर 96 हो जाता है यहाँ से किसी को रिमूव कर दीजिएगा INTC को छोड़ दो ठीक है उसको हम रिमूव कीजिए
Okay, many more people are joining, so just wait for 1 or 2 minutes more. Admit करता हूँ. Okay, so we are starting the session. Welcome to all the participants, faculty members. Okay, welcome to all of you. Welcome, sir. To begin with, I would like to express my sincere gratitude to the management of the college and the organizing committee for their dedicated efforts in arranging this short-term training program, and especially for granting me the privilege for introducing today's session. Thank you, everyone. Thank you for joining, dear participants, distinguished guests, and my dear students. Okay, for today's session, it gives me immense pleasure to welcome Mr. Syed Parvez Alam, Divisional Engineer Civil of West Bengal State Electricity Transmission Company Limited, WBSC-TCL, Kolkata Zone. Welcome, sir.
Thank you.
Thank you.
Thank you very much.
Thank you for
Thank you very much.
accepting my invitation. Thank you, sir.
Thank you.
Mr. Syed
Thank
Parvez
you.
Alam. Thank you, thank you.
Yes.
Mr. Syed Parvez Alam is an alumni of Jadavpur University of the Construction Engineering Department. He has a rich expertise of experience of over 15 years in the industry. From being placed at MN Dastur and Company to working as assistant engineer at the Panchayat and Rural Development Government of West Bengal and junior engineer at CPWD, he has immense experience. He is presently working for over 13 years as divisional engineer at WBSCTCL Kolkata zone, where he undertakes multiple responsibilities at the site, various project works, and in the office at the Kolkata zone. I am immensely grateful to him for accepting my invitation to be a part of this STTP. Welcome, sir. He will be speaking on the topic global construction emissions and the evolution of sustainable materials. Thank you, sir, for coming. The session is now yours. I think we can start the session. The session is
Thank
yours,
you.
sir. Thank you, sir. Thank
Thank
you.
you.
Please
Thank
start.
you very much.
Thank you, sir.
Thank you very much. Head of the Department Civil Engineering, BCET, Miss Pravali Datta, and a warm for your warm and generous introduction. And it is a
Thank
true honor. It is truly an honor to invite me in this immensely prestigious,
you.
immensely prestigious 5-day short-term training program for this sustainable recent trend on sustainable development and global insights also and
Mm.
global emission and sustainable development. I am looking forward to this engaging, meaningful session with all of you. Let's start.
Yes, sir. Thank you, sir. Thank you for sharing your valuable time, sir, with us. Thank you, sir.
So before we start, we are going to tell a little story what all of you heard in the early childhood. The rabbit and the story of rabbit and tortoise. There starts a race in a jungle, and first race they'll start at a point, and first rabbit has a start and go and run faster, and he thought that he has so much time and taking rest in the beneath of a tree, but he fell asleep, and after some time he wakes up and go to the destination point. Then he find that tortoise wins the race. This is not the end of the story. Again, the rabbit and tortoise thought the second part of the second race. They will fight against the second race. Then in that race, the rabbit wins, and again they are again meet up, and they are decide that we are both 1 and 1. So this one is the last race, and we will tortoise says that I will decide the this route of this race. So both have started at the starting point, and rabbit has run through that point, and at one point rabbit has stuck, and tortoise slowly come to that point, and in that point there is a river. So rabbit cannot cross over. So tortoise easily can cross over the river and go to the destination point and be the winner. But they are consulted each other, and in the top of the tortoise, rabbit sat, and both are the winner of the race. So what we are learning, what we have learned from this story is that not only the run faster, but also you have to adapt the situation according to the time, and you have to learn the mistakes from the previous. You have to learn from previously mistake you have done. So in this context, we will start our session. The topic is the global construction emission and evolution of sustainable material in construction industry. So I am here in the construction industry around 16 years. around 15 years I have worked here, and from my journey from the coursework, that is, I have started my coursework in 2006, engineering coursework. From 2006 into 2000, on the verge of 2026, almost 20 years, I have seen a lot of changes in various material and design aspects and various construction activity and various construction technique. There are lots of evolution is there. So today in the global market, in the global construction, today, if we are think, we have in this winter session, we have seen in our, if we are open our door, there are fog every day. We found fog, and we are looking at the AQI of our mobile, and we find it the beyond the permissible limit everywhere. Or in this North India Gangetic Plan, the pollution is so much that AQI level is much more than permissible limit. So it is cause and deterioration effect. So now, what are the causes? There are different causes for this pollution, but we need to change ourselves from this mistake, and we have to change ourselves to be better for this, to make this world better for the future generation. And to little bit of this thing, I have made a small PPT to explain this little bit of thing. So thank you. Let's start. Why the construction emission is matter globally. The global share of CO2 emission from construction and buildings, like embedded and operational emission, is almost for 30% to 20%. 30% is almost is the construction emission share, and there are emission of share. There are two words: embedded emission and operational emission. Embedded emission means the emission which occurred due to production of construction material like cement, steel, aluminum, glasses, and other construction materials. And operational emissions means if after construction is completed, we occupied we in the during the occupation or during the usage of this building, there are operational emission occur. So this is called the operational emission. So there is a chart, we can see the the embedded carbon emission is almost 22 to 2050 become 49%, and operational rest 51%. So both also matters. In why India is important, because in India there are rapid urbanization is happening. From 2020 to 2050, we are became the largest population country in the world. So to accommodate that population, and also there are various infrastructure boom in various sector in India, and there are various scheme of government, housing for all and PM Awas Yojana. The building construction is booming and rapid urbanization. That's why India is the most important for the global emission and construction. Here we can see the building construction material emission. This data is from 2017, where the building material construction is 11% and operation is 28%. And other industry, 30%, global emission, transportation 22%, and others, all others is 9%. So we have to we have to go through the sustainable development model. So next, So what are the India's construction boom and building, urbanization and housing demand in India, rising urban population, migration and housing demand. That is means the working opportunity is limited to the cities and metro city and small city. So that's why there are huge migration which is coming from rural side to urban side. That's why the urbanization and housing demand in urban area is very much, and it is almost in 2022 is it is almost from 2022 20 to 2050, it's became three times. The demand of housing became three times. We have not reached to the maximum housing right now, and similarly, uh, in accordance to matching with this demand, infrastructure also be grown. Infrastructure has to be growth, has to be built to accommodate this kind of housing demand and other infrastructure just like roads, rails, airports, and urban project, and demand for the construction increase. Now, main role, if you see the construction industry, we can see the main ingredient is cement and steel. Cement and steel. So and all other material also combined. The material predominantly used in construction industry is cement and steel. Today's the production of volume of the production, cement is approximately 455 million ton and steel 150 million ton in 2025. And these are the predominantly material used. Now emission is what the emission overview, cement construction material. Cement and construction material. In cement manufacturing, there are calcination and fossil fuel combustion. During production, the cement, there are calcination process and fossil fuel in construction. That is the reason for the emission. And historical cement emission intensity improve over time. Historical improvement in Indian industry. That means the Indian industries and historical improvement is became going to the improve the air machineries, and also in plant uh, they are adopting various major emission controlling equipment like ESP. So the manufacturing emission can be controlled and related. Absolute cement emission rising. Now today in 2023, CO2 emission 177 million ton CO2 equivalent in 2022. And if you see the share of the cement and construction emission, it is around 7% of India's CO2 emission in total industrial in 2023. The cement and other building material. If you see the cement and steel and other building material like steel, aluminium, glass, and other material contribution. Here is the chart. You can see the construction industry emission almost 28%, and both of the in 28% and other 34% in the power sector. And you can see the agricultural CO2 is 17 around 18%. Now in 28% there are cement, lime, mining, refinery and others, and iron and steel. And within the total iron and steel production, construction industry consume around 45% of the that steel, and other industry also use that steel. And cement is wholly consumed by construction industry, and also mining like mining like sand mining or uh, coarse aggregate, that is scarstone, and others mining like flooring material. That's all our mining material are required in construction process. So you can see the chart. Building sector emission in India. Energy use plus material combined share is more important because we even forgot to energy use and operational materials part. We are ignoring the material part during construction, but it is all equally important in building construction phase also, and also when in operational energy use. That means electricity, operational energy use of heating and cooling, electricity demand in residential and commercial building. Earlier, we are used to stay at without AC, without air conditioning. Now, in today's era, air conditioning is an essential product. We cannot live without air conditioning because our temperature, ambient temperature is slowly growing. So to arrest this, we have to go through the sustainable development and cooling demand also. And in hot summer season, cooling demand also required, and in summer season, winter season, we heating also required. So these are the, and for this a huge demand of electricity is growing. So this to mitigate this demand, there are several electric power plant has to be set up, and also uh, to supply this power, we have to upgrade our network system and transmission line system and also substation system, so that we can cater the extra cater the extra demand of extra electric load, so that we can easily get to the everyone, get the electricity to everyone. Now, for this, a huge amount of construction is required and huge processing also required for this upgradation. Now, the projection for the 2022-2027 may be exceed the national carbon budget is more than 47 billion is required to mitigate the carbon. Yeah. The increasing cement production and rising emission demand. As the demand for housing and infrastructure grows, the cement cement demand has been increased. And during in post-COVID construction boom, in post-COVID era pushed the government infrastructure spending and pushing the steel and cement demand, and thus record the emission. The emerging material efficiency and carbon efficiency improvement. Indian cement industry has energy efficient is among the better in globally. They have the move towards the low carbon material and green cement, increasing the awareness. Some farm exploring the greener alternative, and also from government side, policy, a regulatory push also required. Emission norms, monitoring, carbon capture test, and new standard in cement plant also be required. Test bed for carbon capture. Recently, in India, the one committee has been formed and also budget has been approved for the test bed for the carbon capture for steel industry. Emission breakdown. If you look at into the current scenario, what the share comes from the cement manufacturing, chemical process plus fuel combustion, it is almost 60% plus 40%. Now, role of steel in construction emission, the steel demand from the building and infrastructure, and steel making emission are also significantly grown from the earlier, and other material like aluminium, glass, bricks, and finishing materials, they are growing the role, and emission also they are embedded on their production. Operation and embedded emission relative percentage in a building both matter. Yes. Hello. Often under accounted. The projected growth of the emission under the business as well consider rise given construction demand is almost 90.85 gigaton of carbon dioxide, equivalent to the business as well as usual scenario. Now, in this situation, to go to the sustainable, there are some challenges and risks also there are involved. High and growing demand versus decarbonization difficulty. The construction industry is high volume and also low margin, and also is constantly growing at a rapid pace. So decarbonization making very much difficult. And carbon intensive material and versus traditional material. Carbon intensive materials like cement and steel, an alternative, are still limited and expensive. To alternative this, there are material, but they are limited material and but expensive. Infrastructure push could lock the high emission. Large coal-based steel and cement plant expansion to mitigate the new demand. The cumulative carbon budget by 2027, 2070, the building sector emission exceeded national allowable budget under almost 7. Previous slide I have shown 90.85 gigaton of the carbon emission will be occurred. The implementation and monitoring challenge. Though the emission standard exists, enforcement, retrofitting, and monitoring remains difficult. These are the some normal practices during the road construction and building demolition happening in India. Now, what are the recent trend we are going to do the decarbonization, towards decarbonization? Adoption of prefabricated off-site construction component to reduce the embedded and operational carbon. In that case, we are in our organization, we are going to the prefabricated building for large GIS room. That is means gas insulated substation. To install the gas insulated switch gear, we have gone to adoption of the prefabricated building. That is means only foundation is constructed at the site, and other member steel section has been production has been done at the plant, and from there the transport into the site, and it is fabricated at the site, and cladding also, temporary cladding, that is PUF, puff panel or steel cladding, can be produced in a factory and transport to the site and assembling there. In that case, the operational as well as embedded emission can be curbed very much. And there are green cement and low carbon materials. Some Indian cement manufacturing committing carbon neutral target push for the alternative material. The green cement is means and low carbon material. Green cement is actually, earlier we are using ordinary Portland cement, and now we are mixing it with GGBS, that is granulated blast furnace slag, and fly ash in a certain percentage, so that we can using the less OPC, that means less clinker production, and that is the and this GGBS is a byproduct of a steel industry, and fly ash is a byproduct of the power plant. So these also making we are going to this phase, the carbon capture and emission monitoring in cement plant, with the earlier test bed and a stricter pollution norm. So pollution norm should be make stricter, and test bed also be for carbon capture. Test bed has been already started in several cement industry in India. Energy efficiency in building plus better design. To improve the operational emission via designing, electrification and efficient cooling and heating, we have to go for the better design so that we can use natural light in daylight, and also for better designing and heating and cooling. That means to control the heat inside, and also require the less heating cooling in the normal condition, so that energy demand should be less for the operational. And in that case, if we have to achieve the goal, there are policy regulatory pressure plus climate goal. Government awareness of the construction share national emission potential of the carbon budget implication. So there has been a two method. We have to apply the two method. One is the norms became stricter, and there should be a hefty fine, and incentivize the green material, so that for using the green material, someone should be get incentive. So the policy should be for the policy should be formed for that matter. Now, future outlook for and projection. The project construction growth to 2040 to 2050, demand expected to rise, built up area expected to grow dramatically. If current trends continue, the emission trajectory likely to increase in total CO2 from construction and building. Now, net zero ambition versus reality. What decarbonization would require? The material shift, carbon capture, and efficiency. So, if we are net zero going to, then we have to produce less amount, and also make it efficient, so that our embedded operational emission can be checked. The cost investment needs to be for this transaction. Almost 47 lakh crore investment needed for the steel and cement sector to go net zero, as per Council on Energy and Environment and Water, they have estimated. Now, potential emission reduction via low carbon pathway, using green cement, prefabricated carbon capture, better building design, etc. What needs to be done? Strategy and recommendation. Now, in this context, if we are going to through the achieving the sustainable development, we have to promote low carbon or green cement material, incentivizing the green cement, SCM and alternate material, adoption of the prefabrication and modular construction technique to reduce the embedded emission and wastage also. We have already earlier discussed in our department, we have adopted pre-engineered building and modular construction technique also applied in some of the sites. Later I will tell which site I have applied it. Retrofitting of existing building stock and encourage the energy efficient design to reduce the operational emission.
Good morning, sir.
Morning. Energy, the to mitigate, to we have to retrofitting our existing structure, so that new construction is not required. In several various sector, there are retrofitting is now in presently current practices in several bridges, water tank, and there are retrofitting work is going rapidly, so that new construction is not required, and also old used structure cannot be not required to dismantle, so the emission and pollution can be checked. Policy and regulation, carbon standard, emission monitoring, incentive for green building, enforce the stricter norms, give incentive and set carbon budget. These are the policy and regulation to be made for the sustainable development. Long-term vision, carbon capture, circular economy and net zero pathway, and integrating in long-term vision, we have to go for carbon capture. For carbon capture in cement industry, there are already research is going on, and for that budget also has been surpassed. And we have to go for the circular economy. That means recycling of steel, reuse of material, and net zero pathway. That means we have to reuse our own old product and what is wastage product. Integrated carbon capture, recycling, sustainable planning, and renewable energy. And we have to go for the renewable energy. Now, few of the example, recent case study in Mysuru, Karnataka, a leader in green initiative implementing comprehensive waste segregation, composting, solar energy adoption, subsidy for homes building, and promoting eco-friendly transport, cycle sharing and e-rickshaw under the Green City project. These are the recent. In Agra, Uttar Pradesh, a complete large sewage treatment plant using biodigestive technique to clean the Yamuna river and linking the urban infrastructure with ecosystem and health. And several in NABARD micro initiative, NABARD micro initiative support the initiative livelihood like promoting beekeeping in Himachal Pradesh, in intensive vertical farming in Kerala, supporting women entrepreneurs in Manipur through focused funding and training. Now, in material section, recent trend, if you have any question in this part, you can ask me. I will start the second part.
Yes, participants can ask questions. Okay, sir, I think you can continue.
Okay, thank you. I'll continue in second part. Recent trend in
Okay,
sustainable material.
sir, 1 minute. Deep, do you want to ask any question?
No, ma'am.
Okay, okay. Okay, sir, please continue.
Okay. I'll continue. Now we are looking into recent trend in sustainable material. What are the alternative and opportunity? Now, what is the driving change now? We have to, now the driving force behind our change is growing awareness of plastic pollution, waste generation, and climate change. In recent times, we are facing a lot of climate change issue. That is drought, over stormy season, earthquake, and frequent earthquake, and also nor'easter season and high rainfall and very high hot condition. These are the we are facing in current situation. So awareness also increased amongst the us, and it is required. If we are growing awareness, then if we are facing the problem, we have to accept that it was a problem. Then we can change for the change, and we can make the change and policy for the changes required. And government policy and requires and regulations mandate on waste and sustainability, and consumer demand for eco-friendly material and product. These are the main driving force. Consumers also aware, and so they want to eco-friendly material and products. The challenges with traditional material versus plastics. The plastics was accumulated in landfill. Traditional material and plastics waste accumulation, landfill burden, and make huge pollution. High carbon emission from cement and concrete industry, also bitumen manufacturing. And The resources also depletion and unsustainable extraction from our resources. Sustainable material opportunity. We have to go through the circular economy. From waste product, we have to make it resource, and from that resource, we have to make the new material for the lower carbon footprint and biodegradability, recycling potential. Innovation in material science plus supportive policies. In that case, policy also be made for this kind of circular economy. Scope of this production is scope of this presentation: material, biocomposites, recyclable plastics, waste-based material, and natural fibers. The sectors: construction, packaging, automotive, and infrastructure, and lifestyle product also. Recent innovation and case study adoption trends. Now, waste to resource to agro waste. Biocomposite, for example, IIT Madras developed a packaged material from agriculture and paper waste using fungal mycelium and potential eco-friendly replacement for the plastic foam used for packaging and also in building interior works. It also be replaced for the paneling for building interior works. Mycelium-based biodegradable packaging material grown as sawdust, cardboard, and hay using the fungi like Ganoderma and Pleurotus. Benefit is compostable, lightweight, and decent strength, and promising to EPS and EPE forms. Promising alternative to EPS and EPE forms. And this is the IIT Guwahati also developed a material using bamboo plus tulda and biodegradable polymer with good strength and thermal stability, moisture resistance, suitable for automotive and interior and other application. You can see that bamboo strip made in for this panel is made with bamboo strip. Now, so the diversification of sustainable material beyond the packaging and construction. The right side picture, you can see the mycelium board. Mycelium board is look like this, and in the left side you can see the AAC block. Recycled plastic waste is increased being used in road construction, paver, interlocking tiles as a plastic modified bitumen blend. And growing acceptance in viable structural material in green building projects. Use of industrial byproduct and waste material. The material like fly ash and slag, fly ash from the power plant and slag from the steel production, industrial waste being used in concrete blocks and aggregate, reducing the reliance on virgin raw material. And there are fly ash is used in green concrete, and bottom ash part which is settled in the ash pond. This bottom ash part also be used to make the fly ash base bricks and aerated autoclave construction block, and driving low carbon and resource efficient construction practices. As the AAC block or aerated autoclave concrete block size is larger than normal traditional brick size. That's why the construction time also reduce and from the earlier time. These are the driving low carbon and resource efficient construction practices. New bitumen road and road material, biobitumen and enhanced pavement. Using biobitumen from lignin based bitumen and waste biomass, some highway is sustainable alternative to fossil bitumen. Incorporation of waste plastic or modified bitumen or polymer modified asphalt to improve the durability and thus reduce the emissions. Green building material and light efficient and low carbon block. Earlier, I have discussed use of AAC block, autoclave aerated concrete blocks, fly ash blocks, recycled concrete, recycled bricks in new urban housing building. I can give an example. In today, I have a supervising a residential building in New Town, Calcutta. We are using AAC block. All brickworks is done with AAC block. And also fly ash blocks also be used in this site. Architecture urban developers increasingly prefer these recycled plastic pavers and reclaim the wood and rubber flooring from the old tires for the walkway and park interior. And in this part, we are also replacing the normal traditional wood to currently we are using engineering wood, various fiber board like HDF, high density fiber board, LDF, low density fiber board, and MDF board, medium density fiber board, and also engineering wood, also one kind of fiber board we are using. In that case, if you are using this product, the embedded emission is controlled, and also rapid tree cutting is not happening. Rapid tree cutting is much extent reduced. Now, natural fiber and bio-insulation material. Growing use of the natural insulation or eco-friendly interior material like jute fiber board, coir panel, cork, hemp, or natural fiber composites and help to reduce the energy consumption. These are natural fibers are natural product is the natural product, and these are very much reduce the energy consumption, heating and cooling, improve the air quality to support the circular economy, because these are the aerated blocks, and these are the fiber boards, and these are the insulated material, so the heating and cooling is less energy consumption required less in any operational use. Now shift from linear make use dispose to the circular materials life cycle because of the plastic waste, recycled aggregate, and waste research and academic. Indian academic and institution research lab increase the workings of sustainable material innovation like biocomposite from agro waste, bamboo composites, alternative bitumen and green cement, and waste driven materials. In the end of the session, I will show one video. CMERI Durgapur has made their campus waste free by the using the mechanical process, and also use the waste product, that is our normal waste product, waste driven material. The sector wise adoption: roads and highway plastic waste based pavement, use of shredded plastic plus bitumen for the road construction. Over the years, multiple kilometers has been built in many states using the waste plastic. For example, biobitumen. A road was built using biobitumen, lignin base, replacing the part of fossil bitumen, lowering the emission significantly. The example is Praj Industry unveiled India's first sustainable road utilizing lignin-based biobitumen to the fossil-derived bitumen. The eco-friendly road spans over Nagpur to Mansar bypass, NH44, mark a milestone in sustainable infrastructure development. Now, what are the building AAC black, aerated or autoclave aerated concrete block, fly ash bricks, recycled blocks, using the industrial waste and waste-based blocks, paraphernalia for using in housing complexes, and green certified buildings, green interior and landscaping, recycled plastic pavers for the pathway, reclaimed wood for the interiors, rubber tire-based flooring, reduce the demand for the virgin materials, insulation and natural material for comfort, natural fiber-based insulation material, jute, coir, hemp, and biocomposite, all panels to improve the energy efficiency and sustainability. In airport, railway, and public infrastructure, adopting the green material. Some of the airport and railway integrated green cement, recycled material, and waste-derived aggregate as a product of eco-friendly infrastructure push. Modular and pre-engineered building with sustainable material. Shift from conventional concrete-heavy structure to prefabricated and modular building using recycled and sustainable material. Conclusion and the way forward. The policy and regulatory push for green certification, market incentive, and stricter the waste management law, ban on single-use plastics, support for the green material, eco-certification, incentive for the sustainable building material and manufacturing. Summary and road ahead. India is witnessing paradigm shift from the waste and conventional material to sustainable and circular economy driven material. Innovation from academia, growing industry adoption, and single strong momentum. The challenge remains scalability, standardization, cost, but with the policy support and investment and awareness, sustainable material are set to become mainstream. India has the potential to leapfrog into greener, resource efficient nature, benefiting an environment, economy, and society. Thank you, and you can see the video which our preparing.
Now I use Whisperflow. I just think out loud and it creates perfect formatted text on
Before we going to start our next video, CMERI has formed a separator machine for the integrated municipal solid waste management plant, and by this way the CMERI colony is became waste free. And also this plant they have set up in various colony like CRPF camp, and also all other state and other municipality area they have applied this. So now enjoy this video.
Municipal solid waste, a menace in the growth of the country. After many challenges modernity is faced with, disposal of municipal solid waste, or MSW, happens to be one of the most gruesome ones. Management and disposal of MSW has become a major challenge for the urban local bodies the world over. As per the report submitted by the Central Pollution Control Board, the total quantity of waste generation is about 135,198 tons per day, out of which 111,028 tons per day, that is 80%, is collected. 25,572 tons per day, that is 20%, is treated, and 47,400 456 tons per day, that is 35%, is landfilled. In Durgapur Municipal Corporation area, the waste generation is in the order of 250 tons per day. The MSW is classified into two categories: live, dead. Classification is based on source of collection of wastes. The waste collected daily from households, markets, bins, vats, etc. by the municipalities are called live wastes, and the wastes dumped for long periods at landfill sites are called dead wastes. Municipal solid wastes constitute a terrible health hazard for all, people, flora and fauna. The disposal is fraught with risks. Burning the waste at the dump sites causes a high level of pollution. Contaminated wastes and toxic residues from incinerators can pollute groundwater easily and to alarming degrees. Oil-fired and electric incinerators used to dispose waste at low temperatures often result in release of harmful carcinogenic gases. The challenge is indeed very daunting. However, CSIR, Central Mechanical Engineering Research Institute, Durgapur, and Apex Research and Development Institute for Mechanical Engineering, under the aegis of the Council of Scientific and Industrial Research, or CSIR, is standing up to the challenge. CSIR CMERI has an innovative solution to handle MSW in an eco-friendly way. CMERI has designed, developed and installed a mechanized segregation. MSW Management Pilot Plant, its residential campus, where day-to-day waste generated at CMERI colony are being processed with the aim to achieve zero waste CMERI campus. Let's take a look at the process of disposal of live wastes. The domestic waste collected from the campus contains organics and plastics with a little amount of other inert material. The waste requires judicious segregation treatment for disposal. CSIR CMERI has developed mechanized segregation plant, where before treatment of the waste, they are segregated into four primary categories: metallic wastes such as metal bodies and containers, biodegradable wastes like vegetables, fruits, other foodstuffs and grass, non-biodegradable wastes that include plastics, packaging materials, pouches and bottles, and inert wastes such as glass and stones. Generally, the waste materials from households are disposed of in plastic bags. The bags are first dropped in a crusher where the bags are torn off and the materials come out into the hopper. Hot air is passed over the materials so that the surface moisture is reduced substantially, which facilitates the further segregation process. While passing the MSW over a horizontal roller conveyor, it is exposed to hot air in the temperature range of 45 to 50 degrees Celsius. Dried materials are passed over a rotary magnetic drum separator and eddy current separator where the ferrous components and non-ferrous metallic components are separated. The rest of the wastes are sent to the air separation unit through the inclined bucket conveyor. The materials fall from the hopper into the air separation unit due to gravity. During this free fall, the heavy mass falls quickly, but plastics remain in the floating conditions due to air resistance. Floating plastics are being forced to flow into the perpendicular direction using high-pressure air blower. The separated plastic waste is collected in the perforated hopper. The remaining material comes onto an inclined vibratory screen. The sanitary items, large packets, bottles, etc. get blocked over the mesh, and generated vibration facilitate its travel along the inclined surface and finally get collected inside the attached hopper. The undersized materials, mainly biomass, is collected in the bottom hopper. CSIR CMERI has developed technology for utilization of landfill wastes. It will now be useful to take a look at the disposal of dead wastes. The mechanized segregates the dead waste into metallic wastes such as metal bodies and metal containers, fines, that is degraded organic wastes, non-biodegradable wastes, for instance plastics, packaging materials, pouches and bottles, and the inert wastes such as construction debris and stones, glasses, etc. The intervention with CMERI technology can make such segregation a reality. The process starts with the collection of dead waste from the dump yards. Generally, Durgapur Municipal Corporation carry the waste from the dump yard for further treatment at CMERI Colony MSD Complex. The wastes first are put into a rotary sieve through the vibratory chute, which results in the separation of the biodegraded fines. The fines contain mainly biodegraded fines which can be used as manure. After the separation of fines, the remaining wastes are passed over a rotary magnetic drum separator and eddy current separator where the ferrous components and non-ferrous metallic components are separated. What remains thereafter is sent to the air separation system. The non-biodegradable wastes and inert wastes are separated through gravimetric method. After air separation, the plastic wastes are air separated and shredded to specific size. Thereafter, the plastic wastes are sent for its disposal through the pyrolysis or plasma gasification process. Earlier, the wastes such as biomass along with cow dung in surplus quantity are sent to the biomethanation unit. Here the organic wastes are used for biogas production. A complex microbiological process called biomethanation is used for the efficient production of biogas. Biogas production from organic waste is a well-developed technology. In this process, CSIR-CMERI has incorporated different technological interventions to make the process more mechanized and efficient. Biomass grinder cum stirrer has been developed and incorporated in the feeding chamber where the biomass are being grinded and simultaneously is being mixed with fresh water and recycled slurry in the stirrer as a single unit. In the anaerobic digester, when the biogas is produced, the floating dome is moved upward. In this area, CSIR-CMERI has designed an automatic gas extraction system. The ultrasonic position sensor senses the position of the dome and accordingly the compressor switched on or off. The compressor sucks the gas from the floating dome and stores the gas in the storage tank. The slurry coming out of the digestion chamber is stored in the slurry tank. Slurry pumps have been installed which send the slurry in the feeding chamber as per the required, which helps in recycling of slurry water resulting in reduction of fresh water consumption. Biogas is a mixture of methane, carbon dioxide, water vapor, hydrogen sulfide and other gases generated from anaerobic digestion of biomass. The methane gas can now be used as a fuel gas for cooking purpose in the kitchen. The methane gets enriched after carbon dioxide scrubbing. The enriched methane gas can now be used in gas engine for electricity generation. After anaerobic digestion, the spent slurry becomes excellent organic manure that is rich in nitrogen, phosphorus and potassium. After it is dried, the manure is used in agricultural feed. Solid waste materials generated on a daily basis can also be disposed of with the help of electric arc plasma technology, wherein electric ionization is carried out through low voltage in the range of 30 to 50 volts and high current in the range of 200 to 300 amperes between two electrodes. The temperature is raised to as high as 3000 degrees Celsius during the ionization process. The chances of production of toxic gases like dioxin and furan at such high temperatures and anaerobic conditions are bleak. The segregated plastic wastes are first shredded to remove air and to increase the effective surface area. In the plasma gasification process, it is essential to maintain anaerobic conditions. The continuous feeding of the shredded polymer waste is utilized involving the two knife-edged valves operating alternately in tandem. The upper valve is opened, which allows the feed material to enter, and after closing the top valve, the lower one is opened to allow the feed to reach the hearth by gravity. The hearth houses three graphite electrodes inclined to each other at an angle of 120 degrees, which acts as the cathode. At the base is the carbon anode, which when comes in contact with the cathode produces the plasma zone. The electrode position is controlled by rotating the holding knob from outside. The output gases are mainly carbon monoxide, hydrogen, hydrocarbons and carbon dioxide. The product gas, after passing through the plasma treatment, is made to pass through the carbon sieves, that is, redox reactors. This process leads to enrichment of carbon monoxide. The catalytic converter is used to convert any traces of higher hydrocarbon to lower forms and finally into carbon monoxide and catalyst like nickel is used for this purpose. The gas is then cleaned in cyclone separator and scrubber and then cooled in the condenser. The carbon monoxide and hydrogen enriched syngas has high calorific value. The gas is primarily stored in a gas holder and used for generation of electricity with the help of gas engine. Based on the same plasma-based technology, polybag destroyer and models of different capacities have already been developed by CSIR-CMERI, which can be installed as per the requirement. Shredded polymer waste can also be utilized in the pyrolysis unit. Pyrolysis is the thermal degradation of wastes in the absence of air that generates a gas often called syngas, a liquid also called bio-oil, and called char, consisting of ash and carbon. The plastic wastes are heated at a temperature of around 350 degrees to 450 degrees Celsius in the absence of oxygen and the condensable substances in the form of oil, while the non-condensable particles forms the gas which can be utilized in burning, thus utilizing the energy for the heating process of the system, or else can be utilized for electricity generation with the help of gas engine. The pyrolysis oil can be utilized alternate fuel or PAF, which can be utilized in industrial boilers and generators as it has equivalent calorific value of diesel. The CMERI technologies also help in utilization of construction and demolition wastes, or simply C&D wastes. The composition of C&D waste can vary depending upon the types of buildings being constructed or the age of the building being demolished or renovated. CSIR CMERI has developed 20 ton per day C&D waste crushing systems, where the C&D waste can be directly dumped into the feeding hopper from the waste carrying truck or dumper. The dumped waste then shall be sent from the hopper to the crusher through the vibratory chute and inclined belt conveyor. The debris is then crushed in the jaw crusher. The crushed materials then sent into the rotary trommel using the vibratory chute. The trommel has mesh size of 2 mm and 5 mm. The different size material has come out from the trommel. The oversized materials come out from the other end. The oversized materials are being used as the aggregates for PCC. Different works like construction of pavement, car parking and embankment, tar road, etc. are being carried out utilizing these aggregates. The segregated fines coming out of the trommel are mixed with at appropriate proportion with binder and water in the mixing machine. The resultant mixture is the feedstock for bricks. The mixture of optimum quantity is then fed in the die cavity brick making machine. The material is then pressed using the punch. The pressure is being generated and controlled in the hydraulic power pack. This gives the mixture a definite shape. The bricks are then cured in normal water for 7 to 10 days to have the desired strength. Once found to be in order, bricks could use construction materials. CSIR CMERI has developed technologies to convert agro-wastes into briquettes that can be used as effective fuel for cooking purposes. At the CMERI complex, highly sustainable fuel briquettes are created from the dried leaves and dead branches scattered all over the institute and colony area. They are mixed with the slurry of the biogas plant, cow dung, in appropriate proportion, which acts as a binder. This is fed in the briquette making machine developed by CSIR CMERI. They are not only cost-effective, but very desirable for reasons of simplicity in use and eco-friendly aspect. The produced briquettes are first air-dried before being utilized in smokeless stove, developed by CSIR CMERI. The stove has 2 combustion chambers. In the primary chamber, the briquettes are burned and the same fumes are used in the secondary chamber for heating. It has very nominal smoke emission, which is eco-friendly and maintains a healthy working atmosphere for the end user. The use of CMERI technologies has made the CMERI campus a zero-waste colony, and the scientists at the institute are working incessantly to improve the technologies even further. It is expected that the technologies developed by CMERI for disposal of municipal solid wastes will soon spread far and wide and help meet the challenges that these wastes pose to humankind.
Thank you.
Every year, the world generates more than 2 billion tons of trash. That's enough to fill over 800,000 Olympic-sized swimming pools.
Thank you. Any question?
Yes, sir. No, sir. Thank you.
Participants, any question?
Yes, ma'am.
Okay, who wants to ask?
Ma'am, In the modern day, we use alternatives of materials. We can compromise of quality of work, or
No,
the
not at
same
all.
quality is achieved in the alternative modes of material.
Uh, from to this answer your question, we are achieving the same strength, same quality with using the less fresh material. And if you are using the less fresh material, the quarrying and other industrial activity will become less and emission become less. So we are going net zero, not zero. Other alternative material also be used for the reduce of the byproduct of the industry and also agro waste, so that we can we can create a model of circular economy, and also strength will be reasonable.
Okay, sir.
Any other? Any other?
Thank you, sir.
Thank you.
Anyone else?
मैम मैं हूँ
Yes.
Okay. Yes, please ask.
सर हाउ कैन वी ओवरकम द कार्बन एमिटिंग in this environment, sir?
These are the
As we know
factors.
that
Carbon.
in
We have to
construction, we can
in construction.
definitely overcasting the whole process of using materials and which are making the carbon.
We have to use the recyclable material, like if construction debris, reuse of the aggregate and manufactured sand. That is we have to not quarry from the riverbed. We have to making the sand with crusher that emits less emission, and we have to minimize the emission. You cannot stop the emission because you have to develop it, but you have to reduce the larger extent of emission by the adopting these techniques.
Thank you, sir.
Okay, any more questions, please, participants?
Now I have to tell. I have given in the slide. I have tell one of my project site. I have used PEB building, pre-engineered building in Newtown, Action Area 2C substation. There is a PAB building, and there are several also be PAB building. Construction is done in West Bengal State Electricity Transmission Company Limited, and one is another at the nearer vicinity at the Mangalpur substation, where you can go and check Mangalpur 220 kV GIS substation. You can see the PEB building there also be there. And in GIS construction, there are in nearer vicinity, there are several GIS building is construction is going on. One is BAPL, that is Bengal Electropolis Private Limited in Andal area. 400 kV GIS building is also is under construction, and Panagarh GIS is Panagarh 132 kV GIS is fully running in condition, and you can see there are several projects are upcoming. That is Kuilapur 220 kV GIS and other 220 kV GIS also. Other 220 kV GIS also happening. Thank you.
Okay, any more
Thank you, sir.
questions?
Thank you.
Okay, I think any more questions, participants? Okay, I think there are no more questions, so I think we can end the session. Okay, thank you, sir, for sharing your valuable time and
Thank you,
delivering
ma'am.
for delivering such an insightful, enlightening, and intellectually enriching session for us. Our students have certainly benefited through your knowledge that you have shared to them. Thank you so much, sir. Thank you. Thank you.
I also express my immense gratitude towards the HOD and organizing committee this short-term training program, and also basic science department and honorable basic science department and engineering and technology department, both organizing committee, and also feels gratitude, feels immense. I'm happy that you are think myself as a prestigious. I've been happy and also express gratitude that to be a part of this short-term training program. Thank you very much. Thank you.
Thank you, sir. Thank you. Okay, sir. Okay, participants can leave.